we are now going to apply cross-validation to the new data set. So before we do that, I do want to bring up the data set one more time. And I'm going to let you know why. If we just went right now and started cross-validation, we would keep getting 1.0 for the scores, right? And I've told you, anytime you keep getting 1.0s, be wary. Why would we get a 1.0 here every time? Well, let's look at the target column. The target column is whether the rentals are greater than 5,000 or not. And we're using all the other columns to predict that. Well, simply put, if there is a clear mathematical pathway to making 100 predictions, machine learning models will find them. And you can see that we generated the column based on the count column. So it's obvious that you can't easily get it correct every time with the count column there, right? Clearly in the real world, if you're trying to predict whether you're going to have more or less than 5,000 rentals in a given day, you don't know how many rentals you already have. Otherwise, it's a trivial problem, not a machine learning problem. My point here is that we must get rid of the count column for the machine learning problem to actually make sense. So let's do that now. Go ahead and delete df count. Okay, now we're going to do cross-validation on this data set. And it's always worth checking, right? Just do one more check to make sure, did it get rid of it, right? If you forget to run the cell, then it's going to mess it up. But you can see it's no longer there. Okay, so let's now do a new text cell, and I'm going to call it cross-validation, or cross-val score, it'll be more specific. Okay, so I forgot my hashtag. The hashtag makes it a header. Without the hashtag, it's fine, it's a text cell. Now it's bigger and you get the arrows. Okay, so how do we in fact do this? Well, let's start with all of our imports. Okay, so what we're going to do, we're going to import cross-val score and classifiers to use it with. Okay, so here we go. From sklearn.linear model. Wait, that's already the other. Let's do cross-val score first. .model selection, import cross-val score. You can see there are several cross-val options, so go down to cross-val score and select that one. Okay, next, from sklearn.linear model, import linear regression. You start typing, logistic regression. Oh, if it doesn't start to prompt, okay, like in my case, it's like, why isn't it starting to show me what I want here? Because I didn't write it correctly. So I left off this linear underscore model, I think. Yeah, underscore model. Import logistic regression. Now it's showing up. Okay, what else are we going to do? Let's do decision trees, random forest, XGBoost, and we're even going to throw in K-neighbors classifier, which is a new one I'll talk about. So from sklearn.tree, import all these with me. Import the decision tree classifier. From sklearn.ensemble, import the random forest classifier. From XGBoost, import the XGB classifier. And then from sklearn.neighbors, import the k-in-neighbors classifier. This is a great little technique. If you're unsure what something is called, you can actually find it. You scroll down and you start at k and then wait, and then I see it, k-neighbors classifier. Also, with XGBoost classifier, let's go ahead and do the XGBRF classifier, right? You guys are getting some special models in with the XGB classifier and XGBRF classifier. Not many people know about the XGBRF classifier. It's there. If you see a classifier, you can totally use it. Okay, so how are we going to now do it? Well, we need to split the data into X and Y first. And so it's the last column, so we can simply use iloc again, x equals df.iloc for index location, brackets, take all the rows, all the columns up until the last column, And for y, it is the all the rows in just the last column. Okay, and that was verified when we looked at df.head. You can also call it out by name. And now we're ready. Okay, so let's start with cross-val score with logistic regression, just see how it does. Okay, so put in cross-val score as is, and then open the parentheses. And when you do that, you see it's kind of prompting you what to put in. It says estimator. So the estimator is another name for model. So let's use logistic regression. And then you see we want to put in X and Y. Great. So now it's ready to go. It needs a model X and Y, and we can press Shift Enter and see what we get. And we get an error. Okay. Why do we get an error? Look, it's this max iter thing. So I mentioned that before as a possibility. Just go in there and put max iter. They really need to change this, equals 5,000. Okay. Again, each iteration is going to learn from the errors. So it's just setting a higher maximum of iterations to allow it to find, it tries to minimize the error. Okay. If it can't minimize the error, it says, oh no, we couldn't do it, error. So by increasing max iter, giving it more options to find it, you're just helping it not get an error. So it'll converge. Okay, so add that in, try it again, and look at this. Why am I shaking my head? Look at the disparity of scores here. This is the whole point of cross-validation. What, we're getting 98% on one fold and 54 on another? These rounds actually 99 and 55, but oh my gosh, that's a huge disparity, right? So this shows the importance of cross-val score. Now the disparities usually aren't that big. So let's start to think, why might it be that big? Anybody have any ideas? There could be an issue with the last fold, or it could be because it's done by date. I mean, there could be an issue there. One idea is actually we can increase the number of folds. So let's do it again. Try to copy it. So go ahead and copy in the code if you like. And let's do it again, but now change CV. So recall that CV is the number of folds. See, that was 5. Well, let's try 10 and see what the difference is. And the other thing you can think about, hey, if you've got 731 rows here, so if it's splitting into 10 test sets each time to cover the whole data, then your test sets should have about 73. So 10 may be a better default than 5 in general, because the models are pretty big. The disparities are larger, right? We got some 100%, 1.0s, awesome, right? And then 49%. So that last fold is really problematic, and some in the middle. And so it's kind of nice to actually do both. It's kind of nice to see these as they are, all the different scores. And again, these are just percentages correct, because it's doing accuracy by default. But then it can also be helpful to check the mean, right? So this is where I want to just show you in code how it implemented. If you say the scores equals, and then I can put in, let's compare these two. Put in this one, the first one with the default 5 folds, but then I can deliver the scores.mean, okay? And it gives us a mean of 80%, which, right, is the average. That's about how well the model is performing on average. And then I can try it again, but using CV equals 10. In fact, I'll just copy this cell, put it in here. Copying's no good. We've got to write a function. We'll do it. CV equals 10. And you get a slightly higher score of 83. So here is my question for you. Is the second model better? Got a better score? What do you think? It's the same model, okay? Both cases it's building logistic regression with max iteration of 5,000. And it's what it's doing is training and testing on different sets. So yeah, it's a little different because they're training on different test sets. But in effect, it's not like the model is actually better. It's just scoring a little better. Why do I say that? Because when it's all said and done, the model's logistic regression max iter 5,000. Okay, that's what you end up training actually on the whole data set when you're all done. So it's going to end up with the same net result. The goal here is really to see how is the model performing in general. And I think 10 folds is a little better indicative. So I think 83% is probably better indication. Okay, great. What are we going to do next? We're going to write a function to show cross-validation. Okay, and we'll try it with the different models that we have. So, do this with me. Try DEF, and then what are we going to call it? Maybe cross-val instead of cross-val score. Maybe you have a better name, put it in. Not wal, val. And then the input should be a model because it's always a different model. Okay. Okay, so what are we going to do with it? I think it's kind of cool to see the range and the mean. So why don't we show both? Okay, let's show both. All right. So scores equals cross-val score. And then we're going to put in, not logistic regression, but the model, whatever the model is, with x, comma, y. Let's go ahead and set CV equals to 10. Okay. You could change that. You could set a name parameter for that. Now let's print it out. Let's show it. And then let's take the mean. So the mean is going to be equal scores.mean, like we did. And we're going to print out the mean. Now I could return the mean. I'm just trying to be symmetric with my code sometimes. It doesn't matter here because we're not trying to set it equal to something. We're just trying to show it. Okay. But, you know, maybe return is better. I like symmetry sometimes over what's precise. Okay. I think that's okay. Let's do it. Now let's try it. Okay. Let's try it first with, let's just move on. We see logistic regression scores. Let's try it with something new. Okay. What are we going to put in the function? Well, you can put in any one. Put them all in. Do them one at a time. Go for it. See what you get. Let's start with the decision tree classifier. Right, it's not going to get a 1.0 each time because it's, remember, it's doing a bunch of different ones. Right, so let's run it. And cool, you can see it looks great. We got all the different folds. We got a 70% on average. So not as strong as logistic regression. And note we're still getting that tough last fold. And that's what I mean about tough data points. Because if that's your only test set, you're going to think your models are all bad, but it's simply that it's a hard like group of data to test on. That's all, right? This one's much easier to test on. And another piece, by the way, with it is that when I say it's hard to test on, it's also the fact that it's missing from the training set. So it could be that like you need that one to help the training set get stronger. It can go both ways. Okay, try it on all the different models. Can we beat logistic regression or come close? Let me know. I'll try it on the random forest classifier. Close, 78%. Ooh, it got really bad in the last fold, 39.7. Can try it on XGBoost classifier. Oop, cross is not defined. I had a little typo in mine. And cross val. 74, you know, fair. Also, look, it got the same bad score as the random forest one in the last one. And let's try the XGBRF classifier, XGBoost's own random forest. Let's see what we get. Ooh, that's close to logistic regression. 81.82 if you round up. Also, look, everyone's getting the same bad score in this last one, but got some ones, did very well in some other ones. And finally, we've got this k-nearest neighbors, okay? And so what is k-nearest neighbors? Let's run it first and then I'll tell you. 59, not the best. So it got that same score on the last one. If we look at the last fold, interesting that so many got the same one. Logistic regression did better overall, to the best overall, actually. Okay, so how are we going to address this? Well, how are we going to talk about the k-neighbors classifier? That's pretty low. What is k-neighbors classifier? And look, I'm going to just briefly introduce it. I think I could probably find a cool image for you guys. If you ever know what something is and you don't know, look it up, right? K-neighbors classifier, not Kylie Jenner. Thanks, Google. You know, I don't know that the scikit-learn is going to tell you the official documentation, but it does show you the most important parameter, which is in neighbors equals 5. Okay. And if you look on images, is a nice way to look things up. Yeah, here you go. This is nice. It's being recorded, so maybe I should do. Sometimes when I'm look, if you ever want to do things right, you look up the usage rights or Creative Commons license. Oh, and there aren't any, so I can't use any of them. Well, I'll leave it to you to look up, but you can see right there's an idea where you're basically taking the same value as your neighbors. Okay, so if in neighbors equals 5, it's going to pick the same value as the 5 like rows that are closest to it. Like, hey, what's row the new test row? We'll find what are the 5 rows closest to it, and this is what you get. And what's cool is you can change this parameter. Maybe it's better if you take it to the closest 8 neighbors. And it does do a little better, right? So then you're taking the 8 points that are closest to it. If most of them are 1s, it's a 1. If most are 0, it's a 0. That's okay and it works. In fact, why don't you guys play around with it? Try some different values. Can we do better than 66? And you could try anything, right? 10, 70. Moving up. What about 12 neighbors? 73. You can always try the other way too. Try like 3, 55, 15, 73. It's not the case that the bigger the better. If you get too big, it's going to be meaningless. 20, 77. Wow. That's pretty cool. I would say meaningless. I mean, if you had like 200, right? I would think. 25, 25. Okay, so I'll leave that. So I think 20 is good. We got 77. I'll leave that as a challenge to see if anybody can top that, using K nearest neighbors. So there you have an introduction to how to use Crossfile Score to get a better sense of how well your machine learning model is performing, in addition to learning about a new classifier, K nearest neighbors. It's a fun one because you can change the nearest neighbors parameter. All right, guys, keep up the good work.